Today, we'll be looking at indices and logarithm. Indices, logarithms, and sets. Indices, logarithm, and sets. Some of you might have done it. That is the second session of the SHS curriculum, SHS 1. Some of you might have done it, but I know others too might not have done it. I hope all of you can hear me.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir. Yes.
So Samuel Amua, if you still cannot hear me, then it might be from your settings over there. If you're using a mobile phone, press the audio button at the bottom of your screen there and allow audio to be transmitted through cellular network. That might be the cause. Okay, so let's do a little bit introduction. My name is Kumaku Emmanuel. I'll be taking you in additional mathematics. I'm a mathematics teacher in Kwapmeng Senior High School in the eastern region of Ghana. We will not waste much time introducing all of you. We are about 60. If I say I will let all of you mention your names and where you are coming from, it's going to be, it's going to take all the 1 hour. So as and when I mention your name to answer a question, then probably you will tell me which school you are coming from. Good. So we are starting. We'll start with sets. SURDS. Sets. Because of background noise, I'm going to close the microphone, and later on, when I ask a question, I'll open it. So sorry for that. I've closed all of your microphones so that you cannot disturb at the background. So this is the outline of today's presentation. Let's hope that we shall be able to go through all of them. First, we'll look at what is a set or definition of sets. Then we'll look at types of sets. Then we'll also look at simplification of sets, how to simplify a set into its simplest form. Then we'll look at some basic operations involving sets, the 4 major operations involving sets. That is addition and subtraction, multiplication and division. Then we'll also look at the conjugate of a set. When we say a conjugate of a set, what does it mean? We'll also look at that. Then we'll look at how to rationalize a given set, rationalization of sets. Then, after that, we shall look at finding the square root of a set, the square root of a set. So this is the outline of presentation on the section on sets. So without wasting much time, I will start with the definition of a set. Definition of a set. Those who have done it already, when they say a set, what is a set? When they say a set, S-U-R-T. Yes, I can see that there's a hand up. Let me open the microphone for you.
Thank you.
Or is there a message?
No, please.
When you want to speak, you raise up your hand. I'll mention your name, okay? So I have Bedu Abipela.
Sir, please, you said?
Your hand was up. I asked a question.
Yes, sir. A set is the square root of any number which does not give a whole or a natural number, sir.
Good. A set is a square root of any number that does not give rise to what? A whole number. Okay. Any other person? Sian Napala. Your hand is up. What do you have for us?
Sir, hello.
Yes, I can hear you.
Sir, please, a set is an irrational number that cannot be written on the form of A, B.
Okay, a set is an irrational number that cannot be written in the form of A over B. Okay, it's also very true. It's an irrational number. Yes, it's true that it's an irrational number. But okay, we'll come to that. Good. Any other? There are more hands. Let me take one last person. Better Pia Boating.
A set is an irrational root, a number expressed with a radical sign.
Oh, good. So it's an irrational number expressed with a radical sign. Okay. You've all did well. You've done well. Very good submission. Good. Very good submission. So a set is an irrational number. All of you said it rightly. It's an irrational number. When you say an irrational number, a number that cannot be expressed as the square root, as in the form A over B. Oh, where is my pen? Excuse me, I want to connect a writing pad and it seems it's not working. Okay, so I am good to go. So one point is that it's what? An irrational number. It's irrational. So you all did well. When I say it's irrational, it means it cannot be expressed, cannot be expressed in the form A over B. Good. But not all irrational numbers are sets. Example, the pi that we know, pi. Pi is an irrational number, but it's not a set. So we need more clarification. And that is what my colleagues, my junior brother said. All of you did well. It is a square root of the square root of what? The square roots of non-perfect squares. Non-perfect squares. I hope we know what a perfect square is. Yes. Afo, you know what a perfect square is? Afo, your hand was up. You lowered your hand. Kwabena, Obing. What is a perfect square? Okay, I better appear Boating. What is a perfect square?
A perfect square is a number that can be expressed as the product of an integer multiplied by itself.
Good. Any number that can be expressed as an integer multiplied by itself is a perfect square. Apia Boating, can you give an example?
Square root of 2.
Square root of 2 is not a perfect square. Come again. Audrey Esuman.
16.
16, yeah, 16 is a perfect square. Correct. Good. So perfect squares, example. So we have 1 is a perfect square. Then we have 4 is a perfect square. Then we have 9 as a perfect square, 16, 25, etc. Why? Because all these numbers can be written as a product of an integer and itself. So 2 multiplied by 2 will give you what? 4. 3 multiplied by 3 will give you 9. 16, 4 multiplied by 4 will also give you the 16. And 5 multiplied by 5 will also give you the 16. So when you find the square root of these numbers, they are going to yield whole numbers. For example, the square root of 4 is 2. The square root of 4 will yield 2. So this is not a surd. The square root of 100 will yield what? Who can tell me the square root of 100? What is the square root of 100? Mohammed Muniro.
Sir, please, the student can't see the board. Please check.
Oh,
check
my screen is off.
Yes, please.
Oh, okay.
Check.
Let me share it again.
Okay, thank you.
Thank you. Can you see my screen now?
Yes,
It's
yes.
better now.
Yes.
Okay.
Yes, sir.
Yes, sir.
So the square
Yes,
root
sir.
of 100 is what?
Yes, sir.
Yes.
Yes.
10.
Yes, sir.
10.
10.
Okay. Good. So root 100 is also not a perfect square. Root 100 is also not a perfect square. So this is not a surd. Sorry, not a surd. Surd. Good. So we say surd are irrational numbers, the square root of non-perfect squares. Non-perfect squares. So examples of surds. Let me give you some examples of surds. So example of surds include the square root of 2, the square root of 3, the square root of 5, the square root of 6, the square root of 10, etc. Once the number that we are finding the square root is not a perfect square, then we classify that as what? A surd. So in simple terms, a surd is the square root of non-perfect squares. Non-perfect squares. Let me open the microphone for any questions. If not, then we'll move on to the next section. If you don't have any questions,
Sir,
you raise up your hand if you want to ask a question. Maniru, your hand is up. Godfred Boache, your hand is up. Christopher, Obi, okay, you also put your hand down. Kinsley Amwa. Kinsley, you have a question you can ask. Then let's move on to Alice. Your hand is up. If you don't have a question, you lower your hand, okay? Oslas Samoa. Edwin Mensah. Ras. Kufuor. Susanna. Kwajo.
Please mistake. Sir, please.
Yeah, Kwajo. If you don't have any question, lower your hand. Lower your hand. Lower your hand so that I don't mention your name. Kwajo Asokwa. Joshua Kodro.
Sir, please, I do not understand the meaning of perfect squares.
Okay, a perfect square, let's take that again. A perfect square is any number that can be expressed as a product of a number and itself. So let's take that again. So for example, 25 can be expressed as what? A number multiplying itself. So 25 is a perfect square. 36 can be expressed as what? A number multiplying itself.
Yeah.
Six,
Where there is
six,
a name a class.
6 multiplied by 6, please. If you're not called, okay, let me mute everyone and put the microphone off so that I can explain this concept. So 36 is another example because it can be expressed as what? A number multiplying itself. Another example is 49, which can be expressed as what? 7 multiplying itself. Or otherwise, the square of these numbers. So we could have written 5 times 5 as 5 squared, or 6 times 6 as 6 squared, or 7 times 7 as what? 7 squared. So these numbers are perfect squares because they can be expressed like that. And we have many of such perfect squares. Good. So this is just some few examples of perfect squares. I hope the one who asked the question have gotten it.
Yes, sir.
Good. Now let's go to Nana Yeboah.
Yes, I also wanted to ask if irrational numbers, you can also define them as non-terminating decimals which do not recur, right?
Good. Good. So irrational numbers, exactly, that's the exact definition of irrational numbers. So if you punch on your calculator the square root of 2 or the square root of 3, the square root of 5, etc., because these numbers are all irrational numbers, they will give you a non-terminating,
Terminating decimal.
non-repeating decimals. If you have a calculator now, you can demonstrate that. But of course, our calculators that we use, the ES 991 ES Plus, has limitation up to the number of digits it will display. It will truncate the decimal point at a certain level.
Yes.
It doesn't mean that it ends. It doesn't terminate. The decimals doesn't terminate. So the definition you have provided is correct. So all these numbers in decimal, their decimal equivalent will never terminate. Correct. So now let's go to the next person. Mensa Hera. Okay, then we go to Kingsford. Nyako.
Sir, please, can you give the definition of a surd again?
In simple terms, a set is the square root of any non-perfect square. Once you know all the perfect squares, any number that is not a perfect square, when you find the square root of that number, it becomes a surd. Once you know all the perfect squares, when you find the square root of any other number which is not a perfect square, then it becomes what is called a surd. So because of that, let me just list down in ascending order the perfect squares. So in ascending order from the smallest, I can't exhaust all the perfect squares. I'm just listing some few ones in ascending order. So the first perfect square is 1. The next is 4. The next is 9. The next is 16. The next is 25. The next one is 36. The next, who can continue for me?
49.
49. Yes, what again?
64.
64.
81.
81.
64, 81.
100.
100.
And what again?
121.
121, etc.
144.
Okay, so
144.
let's just end here. We can't end the list because it's an infinite set. It doesn't have an end.
Yeah.
It's an infinite set. So apart from these numbers that we have listed, the square root of any other number in within these numbers is a set. So apart from these numbers, the square root of any other number. So for example, the square root of 101, 101 will become a set. So this is a set. I hope it's clear now.
Yes.
Yes, sir.
Yes, please.
Good.
Yes, sir.
So a set is the square root of any non-perfect squares. So that is that. Let's go to Kwaju Akomia. I will kindly entreat Afo to put off the camera. Okay, then Adams Ganiyu. Nana Yabua.
Yes, sir. I also
Okay.
have a definition in my book that was taught.
Okay, let's have a look
Okay,
at
it was
it.
given as they are square roots or other roots that are not written as simple fractions.
Okay, that cannot be expressed as simple fraction.
Yes.
That's A over B. Good. So when the square root of any number cannot be expressed as a simple fraction A over B, then it becomes said. It's true. Good. So because the square root of 36 is a whole number, which can be expressed as a fraction in the form A over B, but the square root of 101 cannot be expressed as a fraction in the form A over B, where A and B are all integers. Good. It is also good. Let's go to Michelle and then Cherish. Then we'll end this session and move on to types of sets. So, Michelle. If
Sir,
Michelle
please, I
is not ready,
wanted
let's
to
go.
ask about the perfect squares, but I think I'm okay now.
You're okay now. Very good. Let's go to Cherish.
So please, how is the one a perfect square? Please, can you explain further?
Because one can be expressed as a product of an integer and itself, or otherwise, you can find the square root of 1 and the result will be an integer. The square root of 1 is what? What is the square root of 1?
Please, is 1.
Good. And 1 can be expressed as 1 times 1.
Okay, so.
Audrey Esuman.
Please, sir, with the definition I have in my textbook, it says that sets are numbers that can be expressed as ratios of two integers, that is P out of Q, where P and Q belong to the set of integers, but Q is not equal to 0. But please, sir, with what you said, it kind of disagrees with what I had.
Please read that again. I want to take it again. Is that read again?
Sets are numbers that can be expressed as ratios of two integers, that is P out of Q, where P and Q belong to the set of integers, but Q is not equal to 0.
No, that is the definition of rational numbers. The definition you gave is a definition for rational
numbers. Yes.
Rational numbers, not set.
Okay.
Set cannot be expressed as A over B. So do that correction. If it's in your notes, you do that correction. If it's a textbook, then it is an error. It can be a typo error or something like that. The definition you gave is a perfect definition for rational numbers. Rational numbers are numbers that can be expressed in the form P over Q or otherwise A over P, where they are all integers except that the denominator will not be 0. When the denominator is 0, the fraction cannot hold. You can't divide anything by 0. Good. Good. So I'll end the questions and answers here, and then we'll proceed to the next session, and that will be types of sets. Type of sets. So we have what they call the pure set. A pure set. A set having only a single irrational number is called a pure set. So these are examples of pure set. Root 7, root 3, root 5, root 2. And they are pure set because, one, it cannot be broken down further. So for example, not because it is just a single number here, that is why it's a pure set. The square root of 8 is not a pure set because when we come to simplification, you will understand the square root of 8 will yield, when you simplify, we get 2 root 2. So it's not a pure set. It belongs to another category. So all these sets cannot be simplified further, but root 8 can be simplified further into this form. So when we are classifying sets, root 8, because it can be simplified, we don't treat it as a pure set. But root 7, root 3, root 5, root 2, root 13, root 11, etc. are pure set because they cannot be simplified further. If you have a calculator by your side now, you can press the square root of 8, and you see that the calculator will display 2 root 2 if you're having the FX ES plus. Let me see whether I can display a version for you to see to appreciate that. Okay. So this is what I want to demonstrate for you to see. I hope you can see the calculator. Can you see the calculator? Yeah, sorry, I've put up the microphone and I'm asking. So I can see a lot of thumbs up.
Yes, sir.
Okay, so the square root of 8, when you press the square root of 8, the calculator will simplify it for you. And that is 2 root 2. So it is not a single set as it is. Good. And then if you want the decimal equivalent, is the decimal equivalent. And as I said, the calculator is only displaying what it can display. It's not just because that is the end. It doesn't end at 125. It is only displaying what it can. The calculator can display up to a certain number of digits. So when you see that the root 8 has either 2.82, blah, 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 up to 125, it does not mean that that is the end of the decimal. Irrational numbers, their decimals does not terminate. It continues endlessly. Let's go back to our working board. So we have the pure set, that is the first one. Then the second one, or the second type we'll look at, is a mixed set. So the mixed set example is the 2 root 2. And that is, you always have a whole number or otherwise an integer multiplying the radical part. So we have like 5 root 3, 12 root 5, 7 root 11. An example is the 2 root 2. When it happens like that, we say this is a mixed set. Then we have a compound set. A compound set joins two parts, join two portions with what? A plus or a minus. So we can have root 3 plus root 10. All of them combined becomes one single set, and it's called a compound set. You can even have a whole number portion and the radical portion, so 3 plus root 7. You can also have a minus sign in between them, so 3 minus root 7 will also be a compound set. A compound set. Then we have the binomial set. The binomial set is when two sets give rise to one single set. The result is known as a binomial set. Good. So root 30, the square root of 30 can be expressed as the square root of what? 15 multiplying the square root of 2. The square root of 15 multiplying the square root of 2. So these two sets, when they combine, they form just a single set, and we classify it as what? Binomial sets. Good. Now, me pause for some few questions. Audrey's hand is up. Let me give her a chance. Yes, woman.
I'm sorry, this was a mistake.
Okay, so let's go to Gifa Town.
Sir, please, can you explain the compound sets again?
Yes, compound sets is a combination of the radical portion or a set and another set, or a whole number and a set with an addition or a subtraction sign. I'll get it. So, for example, let's give more example.
Sir, please, we can't see the board.
You can't see the board?
Sir,
Yes. That might be from your end, because from my external monitoring device, it's showing.
Said the board just went blank.
Yeah, blank. I've opened a blank
Yes.
page.
I see it.
So we are So we are coming to do what we call it. I want to give more example on the compound sets. Compound sets. So it can be a combination of a pure set, two pure sets. When you combine two pure sets together, two or more, it can even be more. So let me write two or more. Combining two or more pure cells. So you can have something like, I have root 3 and then root 2. I can combine them with the operation. We are combining them with the operation plus or minus. So if I combine these two cells with a plus or minus, the 2 becomes one unit set. This is a set. The whole thing is taken as a set. And we call it a compound set. You can also combine it with what? An addition. Okay. That is one way.
Sir,
Yes. You wanted to ask a question?
please, I can't see the board. I can't see.
Then it might be from your end. You can exit and join again.
Sir,
Exit and
please
join
go
again.
back.
Exit and join again. You'll get it. Because it's showing. Sometimes it's from your network. Okay, so let's proceed. Not combining two or more pure sets. It can be combining a pure set with combining a pure set with an integer. An integer. Using what? Plus or minus. So we can have an example such as, if I have root 3 and I have the integer 5, I can combine them with plus or minus. So 5 plus root 3, the whole thing together forms a set. Or I can have 5 minus root 3. The whole thing together is a set. So that's a compound set. That's a compound set. Good. By convention, if I want to combine root 3 and 5 of an addition, if you write root 3 plus 5, it is correct. But by convention, we always want to write the integer part first. So it is like this. This is proper. And best way of writing it. But mathematically, root 5 plus 5, sorry, root 3 plus 5 has the same value as 5 plus root 3 because of the commutative property of addition. But it is best presented this way. You always write the integer first before the said portion. Okay. So let me pause for 1 minute question. Any question on what I've presented so far on types of sets?
Sir, please, why does the integer come before the root?
Okay, so by convention, it is better written that way because even in your one, we see when we are writing with your hand and you don't write the whole number part first, sometimes your whole writing can even be deceptive to the one reading. For example, if I write this like this, root 3 plus 5. Let me write it again. Root 3 plus 5. If somebody is reading it, might interpret it as you actually meant something like this. Meanwhile, that is not how you meant. Is that not it?
Yes.
So to avoid that ambiguity,
Yes, sir.
to avoid that ambiguity, it is better you bring this one here so that in a rush in writing in the examination, the tail here does not seem as if it is covering the 5 as well. You know, in examination, whatever the examiner see, that's what he or she marks. So if the examiner feels like you are implying that the tail is covering both the 3 and the 5, and he marks you wrong, you might not be there to say, oh, that is not what I meant. So this is the best way you present it. You always have to write the whole part first or the integer first before you write. But as I said earlier on, this expression is not wrong in mathematics. It's the same value, but it is best presented this way.
Thank you, sir.
Welcome, madam. Good. So let me listen to Audrey. Your hand is up again.
Please, sir, with the combining of a pure set with an integer, please, sir, does it still fall under the compound set?
But then,
Please, sir, with
come
the
again.
combining of a pure set with an integer using plus or minus, does it fall under the compound set?
Yeah, that is a compound set. The compound set has 2 types. That is when you combine 2 pure sets with plus or minus, or you combine an integer with a pure set with plus or minus.
Okay, sir, thank you.
Welcome, madam. Okay, so we are boxing on. So we are done with
please, I
types of
can't
sets.
hear.
You can't see the screen. Can you see the screen now? Okay, so let's proceed.
Sir, please, I can't hear you.
You can't hear me? Hello, can you hear me?
Yes, please, sir, I can hear you now.
Yes, sir.
Okay, so
Yes, sir. Yes, sir.
Yes, sir.
A little recap, then move on. A little recap. So we have types of sets. We have the pure sets, the mixed sets, the compound sets, and the binomial sets. So we're moving on to the next session, and that is going to be simplifying sets, simplification of sets. Good. So I'll pick the first example, the one we got the 8 roots, the square root of 8. That is the first example I'll pick. The square root of 8. If you're asked to simplify a set, first and foremost, before we can simplify a set, you should be familiar with the perfect squares. The one we listed here. At least you should be familiar with the perfect squares up to 100. At least you should be familiar with them up to 100. At least. And if you can, if you are able to get all the perfect squares up to maybe within 1 and 1,000, that would be good. But minimum, you should be able to list the perfect squares from 1 up to 100. They should be at your fingertips. Minimum should be from 1 up to 100. And I hope you know all of them. So we have 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. We'll be making good use of them. Good. So now let's go back to our question. The square root of 8. You have to express the 8 as a product of two numbers, where one is a perfect square. If you want to simplify, you have to express the 8 as a product of two numbers, where one is a perfect square. So can we express 8 as a product of two numbers where one is a perfect square?
Yes, please.
Yes, please.
Please. No. Yes, sir.
Yes, sir.
No, sir.
Yes, sir.
Sir, please, I have a question.
Hello.
Hello.
Yes, hello.
Yes.
Sir, please, I have a
Hi.
question.
You have a question?
Yes, sir. Please, on the binomial set.
Okay, binomial set. Okay.
Sir.
So let me go back to that place that you asked me. I'm still listening. So ask your question. Binomial set.
Sir, please, the whole thing, the binomial set.
Yeah. But you don't understand, or you have a question on it?
You don't understand.
No, I don't understand.
Okay, when you say a binomial set, it is when two sets give rise to another set, a single set. So for example,
Stop perfectly. Don't waste your time.
let me open a blank page and do that. I think the microphones are many. Let me mute all of you. Good. So the binomial set is when two sets give rise to a single set. So for example, the square root of 2 multiplied by the square root of, let's say, 6, or let me just say the square root of 3, that'll give us root 6. So the root 6 is a binomial. This expression yields what we call a binomial set. By what this? If I have the square root of 2 multiplying the square root of 2, who can tell me the answer? The answer is the square root of 4, which will yield what? 2. So this is not a set. So we can't call root 2 times root 2 a binomial set. But root 2 times root 3 is a binomial set because it yields what? A single set. It yields a single set. When two sets give rise to a single set, we say it is binomial. Bi means what? The prefix bi in mathematics. Who can tell me the meaning?
Double.
Two.
Double or two?
Sir, please, it means two.
Two, correct. So that is correct. It means 2. So when two sets give rise to a single set, then we say what? We have a binomial set. So that is that for binomial sets. Okay. So let's go back to our simplification. And I ask you to tell me the two numbers that we can express 8 into. The product of two numbers said that one is a perfect square. So 8 can be written as what? Nana Yeboah. Express 8 as 4 times 2. And which one is a perfect square?
4.
4. 4. Okay, it's correct. So we can express our 8 as 4 times 2. By the property of sets, we can split this into two separate sets, two separate radical signs. So the square root of 4 multiplying the square root of 2. And since 4 is a perfect square, we can actually find its square root, and that is 2. So the answer becomes 2 root 2. 2 root 2. Okay, let's look at another example. Example 2. The square root of 150. So we have to express that as a product of two numbers, where one is a perfect square. Who can give me two pairs of numbers that will multiply to give us 150, of which one is a perfect square?
Sir, please,
25.
10 times 15.
10. And which one is a perfect square?
Sir, please, 25 times 6.
10 is not a perfect square. It's
Sir,
100.
please, 25 times 6.
I'll go for 25 times 6, but I'll not go for 10 times 5, because 10 is not a perfect square and 5 is not a perfect square. Let's revise the perfect squares again. They are 1, 9, 1, 4, 9, 16, 25, 36, 49, 64, 81, up to 100, etc. So there is no 10. 10 is not a perfect square. 10 is not a perfect square, but 25 is a perfect square. So we can express the square root of 150 as the square root of 25 multiplying 6. Good. Then, as we said earlier on, we can split this into 2. And then the square root of 25 will give us 5.
Square root.
Then this becomes 5 root 6. We have
Yeah.
simplified this set. So let's look at another example again. Good. Number 3. We are simplifying the square root of 420. So we have to first express it as a number times two numbers that are multiplying, but one should be a perfect square. A product. Okay, their hands up. Let me go to Adua saying, Kroma.
No.
Your hand is up. Then, if you're not ready, put down your hand. Maniru. Okay, let me go to the chat room. I have some answers in the chat room.
4
Florence
times
says
105.
4 times 105, and it's correct. 4 times 105, and it's correct. So I'll go with Florence. Florence will take your. But Florence, which one is the perfect square? 4 and 105. Which one is the perfect square, Florence?
Huh? Listen.
4.
What's
The 4 is a perfect square. Yeah, so from
Yes, sir.
Tyrone, Christopher, and Abena, all of them
Sir.
agrees that it's 4. So that is correct. So this will become written as the square root of 4 times 105. Then this becomes the square root of 4 multiplying the square root of 105. We know the square root of 4, that is 2. So the simplified version is the 2 root what? 105. Let's look at another one. The square root, we have to simplify the square root of
Sir,
54.
sir,
Yes,
please
yes.
can you always leave the answer as 105?
Sir.
Can you leave what? The answer as 105.
Yes.
No, we can't leave the answer as 105. The 2 is part of the answer.
No, the 2 square root. Can't you simplify the 105 again?
Okay, let's try. Can we express 105 as a product of 2 numbers where one is a perfect square? Let's see. Can you help us? So let's pick the 105 alone. Yeah, sometimes it happens like that. So let's see whether Madam will help us.
No.
2 numbers that their product will give us 105. The one who said we can simplify. So you can see that 105 cannot be expressed as what? A product of 2 numbers for which one is a perfect square.
Okay.
So that's a simplified version.
I was asking in case when you get one which you can simplify, should we simplify it or should we leave it like that?
You have to simplify. So in case that you get, for example, if here was maybe 110 or something like that, or 125, you have to simplify further
Okay, sir.
because it is not yet simplified.
Okay, sir.
So let's look at the fourth question. Let's look at the fourth question.
9
What are the
times
two?
6.
9 times 6. So we'll express this as 9 times 6.
9 times 6.
The square root of 9 multiplying the square root of 6. And this becomes what? 3 root what?
6.
Okay. You have picked the lesson so nice. Let's look at the last example. We'll look at the last example and then probably we'll look at the last example and then we'll now go to the next session. That's question number 5. The square root of 587. Oh, okay. No, it's supposed to be 5.
Please, if you get it,
No, I'm coming. It's supposed to be 588 rather. Yeah, 588, not 587.
sir, please, what about this?
The square root of 588, not 587.
Please, what about the 2? 196.
Somebody was speaking.
Sir.
Uh-huh.
4 times 147.
4 times 147.
Yes.
Okay. Someone was asking a question. Okay, 4 times 147, eh?
Yes, please.
Okay, let's try that. 147 times 4. Let's see whether it give us 588 is correct. So this will be the example we'll have to break further.
It's correct.
4 times 147 will give us 588. So this will give us the square root of 4 times the square root of what? 147. The 147 also contains a perfect square. So you need to break further. Please mute your microphone after speaking. You mute your microphone.
Please, are you there?
Okay, so the 147 can also be broken down. It has a factor which is a perfect square. So let's break that 1, 2 down. Let's break the 147 down. Two numbers that will multiply to give us 147. One is a perfect square.
13 times 9.
49 times 3.
Yes.
13 times 9.
49.
49 times 3.
49 times 3.
49 times 3.
Is correct.
49 times 3.
So this becomes. Let me put up the microphone for now. So this will be 49 multiplied by 3. So the square root of 4 we know is 2. The square root of 49 times the square root of 3. The square root of 49 2 we know is 7 times the square root of 3. Multiplying these two numbers we have 14. So the final answer is 14 root 3. 14 root 3. That is our final answer in this case. Good.
Yeah.
So that is that. Yes, let me open the microphone for questions. It is 7 o'clock, 1 minute to 7. Hello? I've opened the microphone. Oh, it's not open. So if I,
Please, it's fine.
yes,
Please,
if I
the
have a
question.
so
Oh yeah, hello.
the question was?
The question 4.
Okay, this is question number 4.
Okay. So please, I'm writing it.
Okay.
So please, what about the question? Read again, please.
Question 3 is up there.
Please, the final answer will be 105.
Correct.
Okay.
Okay, so at this moment, you can scan this QR code for your attendance.
Please, how are you going to scan it?
Wow.
So please, how do we see
Okay,
it?
then let me just mention your names because you are going to find it difficult because most of you are using your phone.
Yes.
Yes.
So I am going to I will ask the facilitators to.
Yes.
So I mean, Emilia, are you here?
Students.
When you hear your name, you respond. Emilia Bedu. Absent. Emilia Bedu. Anna Kulampu. Absent or present? Present. Please mute yourself. Let's mark the attendance. Mute yourself.
So Emmanuel, can I come in?
Yes, sir. Yeah, okay.
So kindly show the QR code again. Students, you can still scan it, okay? So let me show you how to scan.
Okay.
Your phone has a menu. When you tap on the menu, or we want you to minimize the Zoom, the meeting link. When you minimize it, look for your camera, your phone camera, open it and scan. Don't leave the meeting, just minimize the meeting, the class. Just minimize the class. Get access to your camera and scan. The smartphone can do 2 things at the same time. Who has been able to do that?
Only I can't do it.
Minimize the menu of your phone. Just press the menu of your phone and you'll be fine.
So what if you are using a PC?
We are using our phones for the
Please,
meeting, so when we minimize it,
what about
camera.
those using the PC?
Sir, please, I'm done.
You are done. Good.
Yes, sir.
Sir, please, I'm done.
Good.
Sir, please, I don't know how to do
Press the
Sir, I'm
menu of
using a
your
PC.
Please, I
phone.
I'm using a
Please,
PC.
what about
Sir,
those
please,
using
what is a
PC?
laptop?
If you are using a PC, means your phone is by your side. Just use your phone to do it.
I don't have a phone.
You don't have a phone, okay. No problem. You mentioned your name, the teacher can
Only
mark
for
you.
Sabe to my laptops.
So now, every time we're going to take attendance. So think about how you will scan it. Okay, anytime we're going to take attendance after the meeting. And so
Sir,
think about
how
how
do you do it?
Please let me tell you my.
Sir, please, I've come.
Sir, I can't do it. I don't
Sir,
get
me,
my
I can't do it.
Sir, please, I
All right,
can't do
good.
it.
Hey, I ain't doing it. I'm just
All right, thank you all. Thank you all. Thank you all.
Sir, please, I
Thank
can't do
you.
it.
We are done. Thank you.
We can't do it.
please,
Teacher,
I
please
can't
over
do
to
it.
you.
Sir, please,
you
I can't
guys
do it.
don't worry. We all
Sir,
can do
please,
it.
my
So
camera
don't
is not.
worry.
Please, I
Don't
can't do it.
worry. We all can do it. So just don't worry.